Hello everyone, my name is Sunny Ravel and today we're going to be talking about the third part of the FBLA Data Science and AI curriculum, which is data analysis and statistics for AI. Now this will be worth 15 points, aka potentially 15 items on your test. Let's dive right into this video. Alright, so the first thing you need to know about is about the certain types of data visualization mediums. So let's just dive right into that. So a histogram shows frequency distribution of a single numeric variable. A scatter plot shows correlation between two numeric variables, which means how those two variables relate to one another. A box plot shows quartiles, median, as well as outliers, which can be very useful. And a bar chart compares categories. So for example, if you have male and female attendance somewhere, you can use a bar chart to represent that data. And then a heat map uses color to show magnitude across two dimensions. So let's start by analyzing each form of data. This might be a little bit broad, but as we start to analyze this data, it'll become easier to look at. So here's a histogram. On the left side we have frequency, and on the bottom we have item price. Let's walk through a few questions together. How many items are priced between $1 and $20? So we're going to be looking at the section between $1 here. As you can see, there's a cluster of 1 to 10 and a cluster from 11 to 20. And we need to see how many items are priced between it, right? So we're looking at this interval because it's from 1 all the way to 20. Now we're going to be looking at the frequencies of each part. So this frequency is going to be 20, as you can see, since it goes up here. And then up here it would probably be around 21. So we're just going to say the 21, and then we'll add them up to figure out how many items are in it. So that would be 41 items. Which specific price interval represents the least frequent items? So the goal of this question is to figure out which bar or which portion or segment has the least frequency. And that's pretty clear to see that it's right here, and it looks like it's around 4. So it would be the $41 to $50 range. So that's our answer there. That's our interval. If an item is picked at random, what is the probability that it costs more than $30? So we're going to be kind of combining it with probability. So the first thing here is we want to see how many data points are above $30, right? So let's look at that. Here, let me actually use yellow to show that we're here. So this is past 30, right? Since this is the 21 to 30 mark. We need to see how many data points are here. This looks to be about, let's say this is 5. This looks to be about 7. So we can say that this section is 7. And then we already said that this section is 4. So now let's add those up. And that gives us 11. So to figure out the probability, we need to take this number and divide it by the total amount of data points. So we know this is 20, we know this is 21. Now let's see, what is this one? Let's say this is 11, 12. Let's say this is, or this looks more like 13 actually. So now we add that all up. So that would be 20 plus 21 plus 13 plus 11 as from here. So that would be 41 plus 24, which is 65. Alright, so that is going to be the total amount of data points. So now we take this number, which is the amount of points above 30, and we divide it by that to get the probability. So the probability that it costs more than $30 is 11 out of 65. So now let's move on to analyzing dot plots. So here we can see a dot plot for daily temperature and visitors for 90 days. A dot plot is used to represent two separate parts or two separate dimensions. So we have a y and an x, and it's used to basically display some sort of correlation or relationship between two variables. So before we start analyzing this data, we'll start by drawing something called a best fit line. And a best fit line goes through your data so that 50% of the values are above it and 50% of the values are below it. So I'm going to go ahead and draw that line. We're going to draw it from, so that looks roughly like that, where 50% are above and 50% are below. So now let's start answering some questions. Correlation type. Does the scatter plot show a positive, negative, or zero correlation between temperatures and visitors? So what does each one mean? So for positive correlation, that means that as x increases, actually let me write it all the way over here. So for a positive correlation, that means that as x increases, y also increases. Now for a negative correlation, it would be inverse. So as x increases, instead of y increasing, it would be decreasing. So y decreases. And with zero correlation, usually it's depicted by there being all sorts of data all over it, where the best fit line is very, very difficult to find. That's when you know there's zero correlation, when your data is just everywhere, like the points are all over the graph. That's a good way to tell. But that pretty much means that one variable doesn't have a very big impact on the other variable, or it might be no impact at all. So now let's answer the question. Does the scatter plot show positive, negative, or zero correlation between temperature and visitors? So let's see. As temperature increases, our best fit line seems to show an increase in the number of visitors, right? So maybe that means the hotter it gets, it seems that the number of visitors also increase. So what type of correlation would this be? It would be a positive correlation. Since one variable increases, the y also increases. Is the covariance between these two variables positive, negative, or zero? Now, if you don't know what covariance is, we discussed it in the last video on probability and statistics, and you should probably go back to that video and check it out and then come back to this one. So now let's answer the question. Is the covariance between these two variables positive, negative, or zero? Covariance implies that if one variable increases, the other also. Positive covariance implies that if one variable increases, the other also increases. So it's very similar to correlation. And we're going to say that since that happens, since we can see that as one increases, another increases, the covariance would be positive. Predictive trend. Based on the data, if the temperature increases from 90 to 100, would you expect the number of visitors to increase or decrease? So clearly, based on our line of best fit here, it's always going to be increasing as the average temperature increases. So we can see the average temperature goes from 90 to 100. And here, most of our data points are way higher than over here at 90. So we can imply that the number of visitors will increase. Now let's analyze box plots. Before we start analyzing this one, we'll look into what are the components of a box plot. So what you need to know is that 50% of the data is represented in this interquartile range. So that would be the entire 50% is represented from here to here. And basically the way a box plot works is you start with the first 25% of your data, the 50% of your data, and then the last 25%. And we can say that from quartile 1 represents 25%, and same thing for quartile 2. Wait, that was cut off the screen, I'm sorry. Yeah, so for quartile 1, it would represent 25% of the data. And same thing for quartile 2, quartile 3, quartile 4. Now remember that the interquartile range represents the data between the first quartile and third quartile. So this is the first quartile and this is the third quartile. And this means that this is going to be this area is going to be the fourth quartile. Because this is the third quartile. So based on that, let's now look at this data right here. Oh wait, I almost forgot to talk about this. Look, this middle part represents the median, and that is essentially the middle of your data. Alright, now let's answer some questions. Which service has the highest median parcel weight? Okay, so as you can see, this looks a little different from this one. It's because there's 3 different box plots here, and this is used to categorize it into technically 3 separate sets of data, and we're essentially going to compare them with box plots, which is very frequent for statisticians to do. So now let's analyze it. Which service has the highest median parcel weight? So as we discussed before, we know that median is this line right here in between the box. So the median for this one would be here, the median for this one would be here, and the median for this one would be here. Now let's look, which one is the highest median? The normal one right here. So the normal service has it. Alright, range and variability. Which service shows the greatest overall range in parcel weights? So range is essentially the maximum value minus the minimum value. So we're essentially going to be looking at how long or how spread are these data. So here it's pretty distant. Here it's relatively small, and then this one is a lot longer. So it seems to look like the overnight express shows the greatest range because the maximum value is all the way over here, the minimum is here. And if we want to actually do it mathematically, we can try to make estimates using this y bar, but it looks, by the eye, it looks like overnight has the highest range. So we are going to do overnight service. Alright, interquartile range. Which service has the most consistent weights for its middle 50% of parcels? So for middle 50%, that means that you want your data to be clumped up very clumped up in a certain area. So this means that your 50% of the data should be in a smaller area. So let me try to draw this out to explain. If this is your interquartile range, this is your big box in the box plot, and you have another box plot that looks like this. And again, these are just the inner boxes. So this is the IQR for both. And we want to see which one has the most consistency. It would be this one, because that means 50% of the data is represented in a smaller area. So the values are all close together, which shows consistency. So now let's talk about which service has the most consistent weights. So now we need to see which one has the smallest interquartile range. And as we can see, that's going to be the normal service. So that would be the answer. Normal service. Alright, now let's talk about bar charts. Now these are going to be one of the easiest charts you'll ever have to do on the data science and AI part, and are in the data science and AI test. And let's just look at what this means. So I'm sure you've seen it before, but so I'm going to be very brief about this. So these are all of the types. It's basically meant to differentiate categories based on two two variables. Like for example, if I have this variable would be categorical because it can be put into a category. So it would be red. Let's say there's red color, 8 children like red, and then let's say there's blue color, 7 children like blue, so on. Now let's talk about, or now let's do some analysis. How many more children chose yellow than chose green? So let's see how many children you chose yellow. It looks like 9 children chose yellow. Now how many children chose green? It looks like 5 children chose green. So it'd be 9 minus 5, which is 4 more children. Which color represents the mode for this categorical data set? In our last video, we talked about mode being the most frequently shown data point. So let's see which color is most frequent. Or to put it in simpler terms, let's see which color has the most children having its favorite. So yellow looks like there's 9 children having its favorite, which is the highest of all. So that means yellow represents the mode. If this survey were used to train an AI model to predict color preference, would pink be considered an outlier, or is it simply the second least frequent category? So an outlier, especially in terms of categorical data, is pretty much a frequency or amount of children that makes absolutely no sense. So if I saw maybe an amount of children like 500 or 1,000 when most other colors are like that, I would likely assume that it is an outlier. But here, pink is simply the second least frequent category because there's even green, which is lower than it. So pink represents kind of a middle area, which doesn't really imply any outlier whatsoever. So it is simply going to be the second least frequent category. Let's move on to heat maps. So these may look a little confusing, but they basically compare magnitudes between two data points, or sorry, two separate variables. So for example, you have the month number, or you have the month and you have the day. So let's kind of do some analysis on this, but before I do that, I wanted to briefly go over what these colors actually mean. So the lighter colors represent lower values, as you can see. So if we zoom in really far, we can see that this is 10 degrees and it's light. And over here in the darker colors, we have way higher with 55 degrees. So essentially they're meant to show or uncover patterns in the data using those color differences. So let's answer some questions. During which 2-month period did Mount Rainier consistently experience its highest daily temperatures? So let's look day by day and see if we can pick up a pattern. Already from day 1, it's looking to me like July and August seem like they're very, very hot months. Same thing for day 2, and it continues on like so. Over here, it seems to switch a lot, but most of the time, the data is shown between July and August as the highest temperature. So now data integrity. Looking at the February column, there are empty cells for days 29, 30, and 31. In data science, is this considered missing data or a reflection of the calendar structure? So in data science, this wouldn't be considered missing data, but instead it would be considered reflection of the calendar structure. Why? Because February doesn't have more than 28 days. So even for 29, 30, and 31, there couldn't possibly have been an error because those days simply don't exist. So it would be a reflection of the calendar structure. Heat map interpretation. If a data scientist wanted to find the absolute maximum temperature for the entire year, which color intensity would they search for first? So they want to find the absolute maximum temperature. And we established earlier that the lower or the lighter colors are smaller values. So they would likely want to go for darker values to find the maximums. So we're going to go for darker values. Thank you guys for watching this video. I hope you learned a lot from it. And if you did, please feel free to like and subscribe. It'll really help me out. And in the next video, we'll be discussing multivariate data techniques. And that's going to be part 2 of the third part of the data science and AI curriculum. I thought it would be way better if I split it into 2 parts because this would be a really long video if it wasn't. Anyways, thank you guys for watching, and I'll see you in the next one.